Okay, next up in section 12.0 on our review of polynomials, we're going to look at question number 2, which says, what is the degree of the polynomial x squared times x minus 3 to the fourth times x plus 2? Okay, so let's first just recall what the degree of a polynomial is. So this is the largest exponent of the variable terms when the polynomial is written in expanded form. Okay, so here's some examples to illustrate what I mean by that. So if I have something like, say, 2x to the seventh minus 4x cubed plus 11, the degree is the, well, largest exponent of the variable terms, and that would be, in this case, just 7. So this polynomial would have a degree of 7, okay? Another example would be something like 5x minus 4, okay? Now when you write 5x, really this is the same thing as saying 5x to the first power. And so this would be our largest exponent in this case. So this would be a degree 1 polynomial, okay? Now, what do I mean by this expanded form business? Well, these two are what we would refer to as expanded form. What's something that's not an expanded form? Maybe something like 2x times, say, x cubed minus 7, okay? This is in what we would call factored form, and we'll talk about factoring shortly in question number 4. But here, it might be tempting to want to say that the degree of this polynomial is 3, right? But since this thing is not in expanded form, meaning, hey, I can here expand this and then rewrite it, right? In order to find the degree, we're first going to distribute this to give us 2x to the fourth minus 14x, and now written in this form, we can say, oh, okay, the highest exponent is a 4, so this would be a degree 4 polynomial, okay? Okay, so now let's check out question number 2. Okay, for number 2, we are given this polynomial, x squared times x minus 3 raised to the fourth power times the quantity x plus 2. Okay, so this right here is definitely not an expanded form. We could do lots and lots of multiplying out here. And in fact, we are going to do some multiplying out, but fortunately when we're asked to find the degree, we just want the largest exponent. So I don't actually have to multiply this entire thing out and get all the terms and then combine them. All I really need to know is what's the largest exponent term that this polynomial expression will produce. Okay, and to figure that out, what we can do is just take one product at a time. So for example, this x squared is going to contribute, well, just an x squared. Now for this x minus 3 to the fourth, this thing is going to be very ugly if I were to, say, actually multiply this all out. Instead, though, what I can just look at is say, look, this would be x minus 3 times itself 4 times. And the largest exponent term that will come from that would be just x raised to the fourth power, right? X times x times x times x. So this is just going to give us an x to the fourth. And then lastly, we're going to have this x plus 2 term, and that's going to contribute just an x when we would multiply that all out. And of course, we would have lots and lots of other terms, but I don't really need to know what those are. I just need to know what this the largest exponent term is going to be. Now notice if I do x squared times x to the fourth times x to the first, that's going to give us an x to the seventh plus a whole bunch of other terms whose exponent are all going to be less than 7. So when all is said and done, the punchline for question number 2 is that this would be a degree 7 polynomial. Okay, very nice. So now let's go ahead and press on to question number 3. Okay, so here we're asked to multiply the binomials and then to simplify our results, okay? So as I said in the last video, this really is the process people refer to as FOIL. So certainly you can call it that if you like. The idea though is really just about the distributive property, okay? So like in part A, I'm just going to distribute in this x here and here, and that's going to give us an x squared plus 3x, and then likewise we go ahead and distribute in this 2, and that's going to contribute a 2x and a 2 times 3, which is a 6, and then it's just a matter of combining like terms. So we get x squared plus 5x plus 6, okay? So now in anticipation of what we're going to be doing shortly on factoring, let's just recall a general pattern here and we're going to see it in every one of these examples. So notice here, to go from the original product here, these two binomials, to our answer, which is this trinomial, okay, to build the x squared, we got that from x times x. How do we build the 5x? Well, we got that from the 3x, the outside term, and the 2x, the inside term. See, those combine right here to build that 5x. So in other words, the 2 and the 3 are adding to produce that 5. Lastly, how do we build the 6? That came from 2 times 3, right? The product of these two numbers here, 2 and 3. So that's how we got the 6. So keep that pattern in mind. We're going to see it play out for these others. Okay, so let's go and do B. Distribute the x. We're going to get x squared plus 7x. Distribute the minus 4, so that'd be minus 4x and then minus 28. And then combine like terms. X squared, 7x minus 4x would be positive 3x and a minus 28. And again, we see that pattern emerge, right? The x squared came from the x times x. The 3x came from really it's 7 minus 4, right? Because you see that right there in the middle. And then the minus 28 came from the product of minus 4 and 7. Okay. All right, now for C, okay, we did this kind of thing in the last video. This is really x minus 3 times itself. So it's really just the same as parts A and B. So distribute, we get x squared minus 3x coming from the distribution of x. Now distribute the minus 3 to give us another negative 3x and then a positive 9. And then combine and you'll get x squared minus 6x plus 9. All right, great. For D, same idea. Distribute that x, so we get an x squared plus 8x. Then distribute the negative 8. That's going to give you a negative 8x minus a 64. And now notice here, right, 8x minus itself, that's going to give us just a 0. That middle term, in fact, drops out. And this leaves us with just x squared minus 64. Okay, and you'll notice here, these two binomials both have x and 8 in them. It's just that their signs are opposite. Okay, and as a result, these two middle terms cancel out, leaving us with this. This is also an important pattern we'll see it come up in question number 4. This is what's known as a difference of squares pattern. Okay, and then lastly, E. Okay, this one just kind of more of the same. We'll distribute the 2x, and we will get 2x squared. Then distribute to the negative 7, and that's going to give you a minus 14x. Then 3 times x, that'd be 3x. And then lastly, 3 times negative 7 would be minus 21. And then combine those middle terms. 2x squared, this would be minus 11x, and then minus 21. Okay, so that's going to do it for questions 2 and 3. We'll look at factoring in the next video.